All right, we are back and better than ever. This is part 2 of discrete probability distribution. So let's get to it. We got a bag full of marbles, 4 are red and 2 are blue. And what are we doing with those? Well, 2 marbles are randomly selected. Well, if I'm selecting more than one object, or there's more than one object, whatever it is, my first question better be, am I replacing the object, the first one? Am I putting it back in the bag, or am I not? Well, I am not putting it back because this says without replacement. If X, my random variable, denotes the number of reds selected, so that is my random variable, find the probability distribution of the random variable X. Okay. Well, what are my possibilities here? My possibilities are, if I'm drawing 2 marbles, I could get 0 reds, I could get 1 red, or I could get 2 reds. And the probability distribution of that is the probability of each of those individual events. Okay, so that's what I'm looking for here. So this is perfect for a tree diagram, so I'm going to go ahead and do that. So let's see. First draw here, my first draw, could be red or it could be blue. Probability of red is what it's going to be. Okay, 4 out of 6, so blue is 2 out of 6. These are going to add up to 1. You can get it from there as well. And then on my second draw, I could still have red or blue. Down here, same thing, red or blue. Let's see how this shakes out. Okay. So let's see, red, if I don't replace, my new denominator is going to be 5. Here's another way you can go about these sorts of things, is you just figure out your new denominator, and then you just have to figure out the numbers of marbles or objects left. For example, if a red is gone, well, how many reds are still left? Well, that turns to 3, and there's still two blue marbles left. If a blue is gone because it was drawn, then there are still 4 reds left, and there's only 1 blue left. So what are the probabilities of each of these events? So that would be, each of these legs would be 4 over 6 times 3 out of 5 equals 12 out of 30. And you might be wondering, well, why isn't he simplifying? Well, I think you'll see why in just a second. This is going to be 4 out of 6 times 2 out of 5, which is 8 out of 30. This is going to be 2 out of 6 times 4 out of 5, which is 8 out of 30, I hope. How am I doing? And let's see, 2 out of 6 times 1 out of 5 is going to be 2 out of 30. Okay, so X denotes the number of reds selected. So what is this? Red, red. So that would be when X is equal to 2. Red, blue, and blue, red, both of these give me when my random variable is equal to 1. And this is the only case where I get no reds and X is equal to 0. So find the probability distribution. Well, I've done it here. I've shown it in a tree diagram. I could do a graph. I'll just do a table real quick because it's just easy to do. But the tree diagram would be good enough. But, you know, a table is a little bit clearer, a little bit easier to see. Now, again, when you make a table, this should be a lowercase x, and then your probability should be capital X. Here go my outcomes 0, 1, and 2. Okay, what's the probability X equals 0? Well, that's 2 out of 30. 1 is going to be 8 out of 30 plus 8 out of 30. That's 16 out of 30. And the probability that it equals 2 is 12 out of 30. And you can always make sure you're right, and this is why I didn't simplify, is you should add these up and it should add up to 1. 2 out of 30 plus 16 out of 30 plus 12 out of 30 does equal 1. They're all between 0 and 1, and so I know it's a proper probability distribution. This is an actual probability distribution. All right, that's it. See you next time.